Okay, we're going to look at another example of using implicit differentiation to find a derivative. So this is actually a lot like the last example we looked at. We've got y in two places here, inside a polynomial function and inside this trig function. So there's no algebra to completely isolate the y. So we have to use implicit differentiation. Why this problem is a little bit more difficult than the last one is what's happening on the right-hand side here, where I have a function that is a product, x times y, inside this sine function. But the basic steps are still the same. It's just going to be the details in the middle that are a little bit different. So we're going to start by differentiating both sides with respect to x. So d dx of the entire left side equals d dx of the entire right side. And then we're just going to go through and do the differentiation. On the left side of the equation, this first term, I'm going to have to use product rule, just like the last example that we looked at. I have 3x cubed function of x times, remember we're treating y as a function of x, so I've got product rule there. Then derivative of 4x is easy. On the right side of the equation, I'm going to have the derivative with respect to x of the sine function, but inside that sine function, I've actually got a product. So we're going to need chain rule and product rule on the right-hand side. So let's go ahead and start over here on the left, though. I'm differentiating the entire equation through at the same time, not pieces and parts of it. I'm going to start by using product rule here. All right, so the derivative of the first function, 9x squared, times the second function, plus the first function, and then times the derivative of the second function. This is where I'm actually going to be using that implicit differentiation. So the derivative of y squared, I'm going to take the derivative of the squaring part first, bring down the exponent and subtract 1, then times the derivative of what's inside there. This is really chain rule, but this happens in implicit differentiation. Every time you differentiate an expression involving y, you can have this extra factor of dy dx from chain rule. All right, then plus the derivative of 4x is 4. And then on the right-hand side here, we're actually going to have chain rule and product rule. So this product is inside my sine function. So we're going to start with chain rule as the overall structure. The derivative of the outer part, derivative of sine is cosine. Leave the inside alone. And then times the derivative of what's inside. So here, when I go to take the derivative of what's inside, that's where I'm going to need to use product rule again. So I'm going to have this cosine of xy times the derivative of what's inside there, and this is where we're going to have product rule. Okay, so here's the two factors in my product. The derivative with respect to x of x is just 1. Derivative of the first times the second plus the first function times the derivative of the second. So this is where I'll be using implicit differentiation. Derivative of y with respect to x is 1 dy dx, or just dy dx. Okay, so there I have differentiated both sides with respect to x, and then I'm going to need to use some algebra to isolate dy dx. So I'm going to do a couple of steps of algebra here. First of all, just removing some of these unnecessary parentheses on the left side. So 9x squared y squared plus this next term, I can multiply the coefficients to make that 6x cubed y dy dx plus 4. All right, on the right side of the equation here, I have this cosine of xy times two terms in these brackets here. So I'm going to want to use a little distributive property here. I've got the 1y, or just y term, and I'm going to distribute through the cosine of xy times that. And then I have the x times dy dx term, and distribute the cosine of xy times that. When I distribute the cosine of xy times the 1y term, I'm going to put the y out front so that it's clear that the cosine function doesn't apply to that. I'm going to leave these parentheses around the xy so it's clear that it applies to those. And then same thing on this next term. I'll put the x dy dx out front times the cosine of xy. Okay, so the differentiation step on this one was a little trickier because I had product rule and chain rule both going on at the same time on the right-hand side of the equation. The algebra is a little bit more complicated also than the last one, but there's always two main steps in that algebra. The first step is to use addition and subtraction to get the terms that do involve dy dx on the same side of the equation and the terms that don't involve dy dx on the other side. So noticing where I have some terms involving dy dx and where I have some terms that do not involve dy dx, I'm going to choose to subtract the 6x cubed y dy dx term from both sides. And I'm also going to choose to subtract this y cosine of xy term from both sides. Okay, with the goal of getting rid of those terms on one side of the equation so that they show up on the other side of the equation. Okay, so let me write down what I have on the left side. These terms could be written in any order as long as I keep the correct sign in front of each term. So we could write these in a different order as long as I have the correct coefficients and correct signs in front of every term. And then same thing on the right-hand side here. I'll have an x dy dx cosine of xy minus this term, or I could write those in a different order. Okay, and then the last main step with algebra is always the same every single time. You're going to factor a dy dx out of the terms that involve dy dx and then divide through by the factor that's left. So the left side I'm going to just copy down. I'm not doing anything with that yet. The right side I'm going to factor out the dy dx. And I'm left with x times cosine of xy on the first term minus 6x cubed y from the last term. And then you want to divide through by that factor that's left. So I'm going to divide through by this x cosine of xy minus 6x cubed y with the goal of canceling that from here. I have to divide the other side by the same thing. Okay, so there is my answer. I don't really have much room left to rewrite that, so I'll just kind of put a box around what our answer is. And remembering that you could have these terms written in a different order. The minus sign should still be with the terms that have a minus sign. So the numerator, for example, could be minus y times cosine of xy first, and then plus 9x squared y squared plus 4. The terms on the denominator also could be in the opposite order. I would want to make sure I have the minus sign with the 6x cubed y term, though. All right.